I think your quizzes might be my top priority for grading, because I think your test is coming soonest. I might be wrong. I'm not optimistic I'll get much graded tonight or tomorrow night, though, because there are meetings. We'll see. Sorry, I'm so slow getting started today. I think I said there might be a quiz Friday. Is that right? Yeah. Highly unlikely. Did I give you the 2-5 handout yesterday? Okay. Good morning, Samantha. Okay, let's focus. Don't know if that helped. Quiz 3, allegedly Friday, if we finish 2-5 and 2-6 today. So everybody, if we don't finish 2-6 today, then the quiz is delayed, even if I don't say it. Does that make sense to everybody? Okay, as I recall, one section is short, but the other one is kind of long. So I don't think we'll finish them both today. Exam 1 would then be Wednesday. Am I on the right Zoom? Because I thought somebody was going to be on Zoom. Well, let's see. Am I recording? Yeah. Okay. It's possible I sent somebody the wrong link. That would be embarrassing. We're missing several people. Who just, did somebody, oh, that was Amber. Hey, Gracie is here. Good morning. Okay, Carter. I don't see Mars yet. Aisha. Here we go. Gracia. You're welcome, Bailey. You're welcome, Sean. Don't tell me you're Sean. Nathan. Oh, I'm sorry. There you go. Yeah. Hope I didn't damage anything. No. Good. Amber. Where's Amber? I'll just leave it for her. Hunter here. Yeah. Hey, Mars is here. Yeah, I'll bring you one. I'll see if anybody else needs one. Mars, I think I have homework for you. There you go. Appreciation reciprocated. All right. I just realized, I think part of the reason I like the word reciprocated is the mathematical connotation. So, I wonder, okay, if I could like redesign my life so that I only use words in communication that have mathematical connotations to them. I think that should be possible. I should redesign the English language and get rid of all the useless words. Let's take attendance. I think everybody is here or excused. Oh my goodness, it's 5 minutes in the class. Sorry, I'm a little off today. Hey, Amber's back. Welcome back, Amber. Okay. It is Wednesday. Good, everybody's accounted for. Yeah, and Raphael and Sean, you don't have 2-5 either. I'll get them for you. One for you.
Thank you.
You're welcome. One for you. You're welcome. One for you.
Thank you.
You're welcome. And hey, you all know you can find lecture handouts on Moodle if you miss class and need it before the next class. Okay. I did kind of have an announcement. Yeah, I have normal office hours today. When are my normal office hours today? It's more than the syllabus says. Anybody remember any of my office hour times today? No, I have a class then. 10:15. Was that a guess?
Yeah.
Okay, you haven't come to the office hours, I don't think, have you? Okay, that wasn't a bad guess. Okay, so 10:15, 1:15, and 2:15. I'll be in there all of those times. If that makes sense to everybody. A lot of days I'm available at 3:15, although I prefer those be scheduled ahead of time. Today I'm not. There's a last minute, well, there's a lot of stuff that happened yesterday. One of those leads to a 3:15 meeting today. So I won't be in there. Well, I will be in there, but I won't be available for office hours at 3:15. Some of these meetings last for hours and hours. This might be one of them. Tomorrow, I think I'm available at 3:15 tomorrow, though. Okay. You can still slide homework under the office door. Okay. Basically, if you slide homework under the office door before the meeting ends, it would count as handed in before 3:15. Does that make sense? It's just I won't be able to help you at that point. So, but I can help you any of these times: 10:15, 1:15, and 2:15. Does that make sense to everybody? Okay. It's going to be a closed door meeting. So just, I guess I'm asking, please don't knock on the door at 3:15 unless like it's an emergency and you're dying or something and a mathematician can help you. So, okay. And actually mathematicians are not great at saving lives. That's kind of sad. Okay. I don't think I've ever saved a human life. Should I feel inadequate? I think in a way I save lives just by improving people's lives, right? Okay, mathematics does that. Yeah. I'm babbling. Okay, quiz 2 probably, or quiz 3. Quiz 3 is probably Monday. If we do not finish 2-6 today, then the quiz will not be Friday. Ask me at the end of class if you're not sure. Quiz 2, I've now graded twice as much as I had on Monday or on Tuesday. So I've graded 1A and 1B. That was the domain and range, and the graph for a shifted graph. It wasn't shifted, it was compressed and reflected. So these are the scores right now. That one, it wasn't a high scoring problem. People did better on the domain and range part. Should have one here. Here it is. Anybody have a question? Any policy schedule? Or is there a homework question anybody is stuck on? And I think 2.2 part 2 is probably due today, right? No, it was probably due last time. Because you had a quiz on it on Monday. So I don't think anything's due today. 2.4 would be extra credit today, right? Okay. How many of you finished 2.4? Okay. Any of you get stuck in 2.4? I know I graded 1 or 2, but does anybody have a homework question right now? Okay, how many of you have printed off quiz 1 from Moodle? That's not most of you. Why not the rest of you? Why didn't you? Quiz 1 from Moodle. After I graded them, I posted blank copies on Moodle. So why didn't you print it, everybody? Have you been busy with other things? That makes sense. Okay. Print them. You don't want to wait. You should. Have you gone over the quiz again, Amber? Okay. Everybody, you should. Don't. It's not like you can study too soon. So you know what I'm saying? You're going to keep studying. You're going to keep practicing the online quiz until you're getting it nearly perfect every time, alternating both forms to get the most practice. That's how you prepare for the test, which is next week. Next week is the test. Okay. And I think I said also I can record video solutions if you can't make the office hours. I can make additional practice problems like a third form of the quiz. And I can record a video with solutions to a third form. I didn't even notice Raphael leave, but he's back now. Okay, let's go into 2.5. 2.5 and 2.6 in the old edition of the book, they were in the opposite order. And I don't really know why they got switched. 2.5 is a little more abstract. Who here is an intro to abstract? So Peyton, Amber, was anybody else here in intro to abstract? Yeah, Nathan, I remember. I was there yesterday. So, okay. Higher level mathematics is actually all proof writing. And that's where intro to abstract is heading. So you don't necessarily deal with numbers, you're dealing with abstract sets. So does that kind of make sense from what you've seen in that class? So like you had an example yesterday with Star Wars characters. So Oh, Aisha's in there too. I'm sorry. I forgot you. So, right, in Intro to Abstract. So just the four of you, I think. Okay. This section lends itself a little bit more in the abstract proof writing direction. We're not going to write a full formal proof here, but I will ask you to carefully explain some things. It's actually not really in the same direction. It's not the same type of abstraction that you see in Intro to Abstract. This is more specialized. But I will be testing you here on precision of writing. So using notation correctly and just saying exactly the correct thing. There are times in mathematics you can write things in different ways, and I allow imprecise statements as long as it's the right idea and the right conclusion. Yeah, and essentially the right work. Some problems here will be a little more picky. Okay, so consider the function graph below. I often start off with review problems. Find f of -1 and the limit as x approaches -1 of f of x. Now, I suggested you draw a vertical line. And again, the reason is you're only going to look for y values on this vertical line. I find without the vertical line, people start straying to other parts of the graph. Okay, f of -1. What do I look for a function? What do I look for on the graph? Point, yeah, which it's a closed circle, or it could just be, like wherever you have a curve, every point on the curve is actually implied to be a closed circle. But we do have one close, these are not on the vertical line, this one is. What's the y value? -2. I actually feel like I already went through. Maybe you had a graph like this in an earlier section. It feels familiar. Okay, limit, the limit, it doesn't matter. Well, the limit doesn't notice isolated points. Okay, it follows the curve. It doesn't matter if the curve goes to an open or a closed point. Yeah.
So the other open circle at 2, you would
has no effect on the function.
gotta be a point.
Yeah, yeah. And for a function, it doesn't matter if there's a curve going to the point. Okay, so if this point had been like in the middle here with nothing coming to it, it would still count for a function. But for a limit, you follow the curve. For the limit, we can follow this way and this way. So you have two different curves that they meet this vertical line here. Okay. What are the two y values? -2 and 2. Which one do I use for the limit? Do I just average them? For the limit, though? Neither. Yeah. Well, okay. For this notation, we did one-sided limits last section, right? Okay, they would both be one-sided limits, but this is a two-sided limit because there's no plus or minus after it. Does that make sense? So we have two y values from different directions for the limit, and the limit does not exist because it cannot simultaneously equal -2 and 2. So for this limit, it's a DNE. And again, for a limit, it doesn't matter if the endpoint is open or closed. It just matters if there's a curve coming to it. Now that's review. Does that make sense to everybody? Any question? Okay. There's a very intuitive notion here which factors into a lot of theorems. A function is discontinuous wherever there is a gap or hole in the curve. It's continuous wherever there is no such gap or hole. So the idea of continuity is the noun form here. The idea of continuity, try tracing the curve, let's say from left to right. You can trace it here without lifting the pencil, or pen in my case. When you reach the open circle, you have to lift your pen across that open circle. Does that make sense? So that's a discontinuity. Part B is asking at what values in -3 to 3 is f discontinuous? So it's discontinuous at -2 because there's a gap there. Then if you keep tracing, so an open circle in the middle of a curve is always a discontinuity. You keep following the curve, at this point there's a jump. You have to lift your pen and move it to the other curve. Does that make sense? So that's x equal -1. That's our second discontinuity. So a discontinuity can be a hole or a jump. You can trace the curve here. And then at the top, you have to lift the, what's happening between these two curves here? There's a word for it. Begins with an A. Asymptote. Yeah, that's another great word. So it just occurred to me, I don't use the word asymptote in ordinary conversation nearly often enough. We all should do that more. Okay, note to self. Fix English language. More math. And say asymptote more. Yeah. The word asymptotic should absolutely be used in religious settings all the time, because it's about things approaching infinity. So approaching divinity in a sense. Okay, and actually there were mathematicians who looked at it from that point of view, but the one in particular unfortunately went insane in the end. Anyway, that's a digression. Asymptote, for a vertical asymptote, you have to lift your pen across the asymptote to go from one curve to the other. Does that make sense? There's a gap or a hole, between these curves here. So x equals 2. Those are the 3 discontinuities. The curve is continuous everywhere else. Does that make sense? Now, the problem said what values in -3 to 3, and those were the x's. Those were the graphed part of the domain. So we define continuous and discontinuous only at x values, not y values. So you should, for this kind of a question, don't give y values in your answer. It's like domain. Continuity is defined within the domain, not the range. Any questions so far? Does it seem intuitive that discontinuous is where there's a hole or a gap, and this is kind of a different sort of gap? So does that make sense to everybody? Why do we care about this? A lot of theorems only apply where a function is continuous. At discontinuities, you can get much more complicated behavior. Some of the big tools of calculus, well, one of them called the derivative, it doesn't work at discontinuities. The other one actually does work. I suddenly feel like mentioning, this is a slightly simplified definition. So note to self. Comment or appendix. The harder def. In higher level math classes, like graduate level, I actually saw these things my senior year as an undergrad, but it's like a 300 level abstract class. There are harder, well, okay, there are more complicated functions that are so complicated you really can't draw them very well, that have infinitely many discontinuities. And this definition is a little too simple for such a situation. So there is a harder definition of continuity. Engineers don't use that definition. You have to really go out of your way to find strange functions where that definition applies. And actually, those are pretty exciting functions. It's just they don't get used a whole lot outside of mathematics. And they really are right at the border between undergrad and grad level. Okay. I have defined continuity at points. So I'm talking about a function being continuous at one x value. There's a second definition for a function being continuous on an open interval. Some of these definitions can vary a little bit from book to book. What we go with in your book here, a function is continuous on an open interval if it is continuous at every point in the interval. So I think that's probably how you would interpret it. So as an example, is this continuous at 0? Yeah, 0 would be here, right? Is there a gap or hole there? No, so it's continuous at 0. Is it continuous on this whole interval? Like going from -0.5 to 0.5? Yeah, there are no gaps or holes anywhere in there, okay? So you can talk about continuity at a point or on an open interval. And you'll see theorems that do it both ways. Okay, there are different types of discontinuities. Some of them are better behaved than others. Well, the definition, oh, I'm sorry. For part C, which discontinuity can be removed by adding or changing a single point on the graph? So when I say adding or changing, basically I mean you can fill the discontinuity with just one point. Is there one of these discontinuities you can fill with one point? There's no way you can put a point that would bring these together because they go up to infinity. Okay. Here, there's no way one point would bridge this gap. So do you see this gap is too large for one point to fill it. This gap actually is infinite, so a point won't fill that. The horizontal distance is not infinite, but the gap goes infinitely high up. There's no way one point would bridge that whole gap. So does that make sense? This one here, if I put a point in that hole, would that make it continuous there? Yeah. So at x equals -2, I know what to do. Okay, x equals -2 is removable. Is that point misaligned? Does it look like that open circle is a little to the left of -2? Yeah, okay. Realign. That point was supposed to be at -2. I'm not quite sure what happened there. I really don't know what happened there. It's the way I set that up, I don't know how it would have gone astray. So there are three types of discontinuities. A removable discontinuity is a hole in the curve like this. That's removable. It can be filled with just one point. Oh, come on, where'd all my pens go? Here they are. This pen is dying. A jump discontinuity is a jump from one level to another. So that's this one. We jump from 2 to -2. So I'm in part D here, identify each by type. Removable. X is -2. Jump. X equals -1. So you see the difference. Removable is a hole. Jump is, well, jump from one level to another. We say removable because it can be removed by inserting one additional point or possibly moving one point. Do those two make sense? The third type is infinite. An infinite discontinuity is a vertical asymptote, or it occurs at a vertical asymptote. So that's x equals 2. So removable discontinuities are less severe in the sense that a discontinuity makes a graph a little less well behaved, a little harder to analyze. A removable discontinuity is less severe. A jump discontinuity, more theorems are going to break there. An infinite discontinuity is the least well behaved. So even more theorems will break there. So any questions there? Basically, removable is the preferred class of discontinuities. So there are theorems that work at removable discontinuities, but not at either other type. Any questions on the first page? Let us proceed. All right, next one I'm going to do on paper. There are two more examples here. These, yeah, the first one, I'm going to do it step by step. You don't have to do all of these steps for the homework, though. I'm doing this just to kind of show you where things are coming from. So we have a piecewise defined function, f of x, x squared. Why am I in a good mood today? I hate meetings, and I have tons of meetings. But I think I can see a day past the meetings now. Maybe that's why I'm in a good mood. Okay, we have these three pieces. Parabola, horizontal line, non-horizontal line, slope 3. I want to, in part A, find the limit as x approaches 2 from the left of f of x. And I want to find f of 2. And I want to find the limit from the right. It says use proper notation to carefully explain. So, sometimes in previous sections, sometimes I didn't write the limit in front. I would just use arrows to kind of indicate that it's a limit. Do you remember that? When it says use limit notation to carefully explain, that means I want you to show the limit notation wherever it's appropriate. Something else to, I guess, keep in mind now, you should never write a limit with something under it without a function after it. That's a common error, okay? So for proper notation, your limit should have something under it and something after it. So let's start with the, well, which of these do you think is easiest? F of 2, which piece? This says X is 2, so which piece? Middle. Y is 4. This returns the Y value. There's not a whole lot of notation or anything there, but I do want you to label it. Some of you, I'd say, are more careful with how you write your solutions than others, and that's not necessarily a big deal at this level for the most part. But the problem, because that was a sneeze, right? The problems where it says carefully explain, you do need to be more careful with how you present your solutions there. Okay, limit as X goes to 2 from the left of F of X. 2 from the left, are we looking at X is less than 2 or more than 2? Which did you say? Less than, yeah, less than. On the number line, the left has less than 2. So the way I would write this, I'm going to write something down and I'm going to make an error, then you're going to correct it. So we look up the piece. From the left of 2, that means X less than 2, that's X squared. So I'm going to use X squared. Am I missing anything? And the fact I left a space in front might be a clue. Is there anything I could logically put in that space?
A negative.
Negative? Why a negative? Oh, for the left part? There will be a negative there. We want the whole limit in front. Limit as X goes to 2. Now, in fact, you don't need to have the minus anymore here, but it would be okay with a minus. The minus just tells you which piece to use. Does that make sense? If you still have X's, then you need a limit in front. In this problem with careful notation, if you have X's here, you still need the limit in front. Does that make sense? Okay. What's my first instinct in evaluating a limit? What should I do first? Plug it in. Usually that's too easy, but in this case, it works. 2 squared is 4. It's not indeterminate. That's the answer. Okay, that's the left-hand limit, which equals the point. So any question there? What do you think I should write for the right-hand limit?
Limit.
Yeah. Limit as X goes to 2. It's okay if you still have a plus there. Wow, this is smudging pretty bad. 3x plus k. Okay. So the plus tells you X is more than 2. That tells you 3x plus k for the piece. So you plug that in here. Substitute the 2. You get 3 times 2 plus k. So remember, the variable is X. It's not k. K is some unknown constant. It's not the independent variable. It's also not dependent. It's just a constant. So do you see what I did so far? Everybody? Let's simplify. What do I get? Yeah, 6 plus k. So if you still have an X, you need the limit in front. When you plug in the X, you don't need the limit anymore, okay? The limit is actually telling you to plug in the X. If you look in the book, they probably use proper limit notation all the time on every problem. And if you look online, there are a lot of videos where people do that. Technically, that is how it should be written every time. But at this level, and especially on more of the applied side, that's it's just not a big deal, really. So, okay. Unless the problem says, then you have to do it. So any questions on A? Yeah, yeah. Was that Mars? Yeah. Okay. In a sense, we have infinitely many answers depending what K is, but yeah. Any question here?
Why did we use 2 if 2 is not included in this? Like, it's not.
Not in this piece, you're saying?
Uh-huh.
Yeah. Okay, technically for every limit, you're only using x as close to that limit, but not equal. Okay, now that makes sense, on graphs, for instance. We don't care if there's a point there, we just care what's happening close to that point. So it's kind of a shortcut, but just always your first instinct is to plug in the x and see if you get a good answer. Okay. So it's just, that's the way limits work. Limits follow the curve, and this is the curve we're following. Does that make sense? Okay. It does seem counterintuitive in a way. So I think my second answer is the better one. We're just following the curve. We're not looking at the point itself. In part B, I want to look at how these three pieces fit together. So is f of x continuous at x equals 2 if k equals 1? Now, let me caution you, what I'm about to show you, you don't need to do this on the homework or the quiz or test. There's going to be a more concise way to do it. But this shows you what's happening here. This is for context. Okay, the top piece is what kind of curve? Parabola. And it goes to what we saw here. The limit following the parabola is 4. So we have an open circle at 2, 4. For now, it's an open circle. The parabola, that's not my best looking parabola ever. It continues in the other direction. That's not too horrible looking. So does that make sense? That's the first piece. What does the second piece appear as on the graph? A point. So, and the point is 2, 4. So it fills the hole. So those two lined up. Okay, we do not have a discontinuity between the curve and the point, not this curve and the point. Now, if k is 1, here, 6 plus k would be 7. That third piece, the second limit here would be 7. Okay, I didn't space this very well. Gesundheit, who was that? Samantha. Yeah, thank you. Or yeah, something. Okay. I try to think of a way not to have to redraw this, but I think I better. So I just need more space at the top. I was up at 4. So here. Now. In some ways, it looks worse than the previous one. Okay, then the line starts at 7 up here. It's an open circle. There's nothing to fill it. What's the slope of that line? 3, right? Slope is 3. So go up 3 over 1, or let's go backwards. Down 3, back 1. That'd be here then. Let's see if I can draw a straight line. Holy cow, that was horrible. I went the wrong direction, didn't I? Okay. So it's this way. I'm going to draw that again because I botched that so badly. Third time's a charm, but it's a little embarrassing. Are you embarrassed to be in the room with me right now, as bad as I've been botching this graph? I think you should say yes. Payton?
This isn't in our classes.
That's true, but this was a math error. That aren't you embarrassed? This blatantly was not a function. It failed the vertical line test. Well, okay. You might be a little too forgiving. I can't believe I said that. That was just rude of me to say you're too forgiving. Okay. All right, up here we go up 3 over 1. Okay, that's the graph I had intended. So does that make sense? Can't believe I did that over here. That's so embarrassing. Is this continuous at x equals 2? The whole thing? What kind of discontinuity? Jump, yeah. Not continuous. There's a jump discontinuity at x equals 7.
X equals 7.
Holy cow. What does X equal? 2. Thank you for catching that. Amber, are you still not embarrassed to be in the room with me? Well, okay. Yeah, Peyton is. Any of the rest of you leaning towards embarrassment now?
It's not a big deal.
You're no longer embarrassed?
No, it was sarcasm in the first place.
Was it really? Well, I guess that makes sense. I was thinking it looked like a joke, but it was also a joke based in reality. So nobody's actually embarrassed. Okay, that's very kind of you. All right. I'm a little tired today, so that might be causing the errors. I think most of you are probably more tired than me, though. So for a certain K value, we could close this gap. What happens is when you change K, this thing moves higher or lower. What your homework problem is going to ask for is to find the value of a constant that removes the discontinuity. To do that, we're going to use a theorem. I'm not going to write it. I'm just going to refer to it. I'm going to apply it. So here, for f of x to be continuous at x equals a, the following must all be equal. F of a, the left limit, and the right limit. Okay, what that means, the left limit would be a curve coming from the left. The right limit is a curve coming from the right. What would f of a look like on a graph?
A point.
Thank you. Yeah, a point. Exactly right. So to be continuous, all three of these things have to line up together, right? So if these are not all together, you have some kind of discontinuity. That's what the theorem is saying. The left limit, the right limit, and the point all have to coincide or be equal. Everybody okay with that? Now, you will not need to show a graph on these problems in the homework, okay? But I'm doing it just to tie things together. So part C, put a star next to part C, because that's the one you're going to follow in the homework. It's okay if you follow the other parts, but you don't need to. Part C is asking, what's the value of K that makes this continuous? Use the theorem, carefully explain. Oh, it does say show a graph. You do not need to show a graph on the homework. The comment below says that. Well, okay, I want you to invoke the theorem. So here's a good way to do it. Continuity at x equals 2 requires the following. I'm about to do something daring and, like, I don't know, rebellious against grammar. So you might be embarrassed to be in the room with me in a moment, or scared even. Okay, to all be equal. All right, does that make you feel a little, like you're in the presence of a madman to see somebody say that? So what's the grammatical oddity here? What's odd about that? There's a phrase for it. So you identified it because, well, because there only are 4 things here, but also because you could see it looked a little weird. Do you know why, though? The what?
Does it stand for like a symbol or something?
No, I don't think so. Oh, 2LB. No, I wasn't, nothing like that. Okay, 2B. I'm going on a digression here, but in grammar, what kind of thing is that? When you have like to and then a verb. Am I wrong? Isn't that an infinitive? To be or not to be, but am I right that an infinitive is when you have to and a verb? You've all taken grammar more recently than I have. Oh, I might be wrong. It's not saying that. Okay, infinitive example. To be, yeah. Okay, see, that's an infinitive. Didn't you learn that at some point? Seriously, you didn't? In school, anywhere? Maybe they don't talk about that anymore. My last English class was like literally in the 80s. And I remember that. Okay, so do you know what it's called when you have a word in the middle of an infinitive? It's a split infinitive. You've seriously never heard of that? It's considered bad grammar officially. And I just felt like being, naughty here, really. Let me look again. Split infinitive. And then I'm going to ask you for the most famous split infinitive. So, oops. Split infinitive. Yeah, grammatical construction in which something separates those. So it's technically improper. Okay. Are you all familiar with Star Trek, a TV show and a bunch of movies? Have you heard of it? Have any of you ever seen any of the movies? Mostly no. You had paid it. And how many of the rest of you have seen a Star Trek movie? Maybe you might not have paid attention to the whole thing.
Dad loves it.
Does he? That's excellent. Your dad's very cool, I think. So, and then there are TV shows, right? So do you know the phrase they say at the beginning of the original Star Trek? Well, there's kind of an opening monologue, but it says to boldly go originally it was where no man has gone before, and later is where no one has gone before. But to boldly go, that's a split infinitive. Does that make sense? So I did it too here. Okay, anyway, let's get back to the math. Do you think I scared or pained Aisha to leave in the room? That might have been a painful thing to sit through. Okay. Should I apologize when she comes back? Okay, I can do that. Should I apologize to all of you? Bailey?
I just think it'd be funny.
Apologize when she comes back?
Yeah.
Oh, to all of you?
I don't know, just to her maybe.
What?
I feel like it'd be funny just to her, just because she like left.
It'd probably confuse her.
Yeah.
Okay. But I will say that Bailey told me I should apologize to you when she returns. Okay, for splitting the infinitive, right? It's kind of a, I don't know, that's transgressive. Would that be a good word for it? It's a transgressive action. It's a transgressive morning for me, apparently. Okay. Requires the following to be equal. It's these three things. So I'm just going to state them again. I already computed them. I don't need to show the computation again. So limit as x approaches 2 from the left of f of x is 4. F of 2 is 4. And the limit as x approaches 2 from the right of f of x is 6 plus k. Now, k does not equal 1 anymore. That one didn't work. We're going to find the k that works. This is the statement of the theorem. Theorem tells me these three things must be equal. If you had not computed them previously, you would show the steps for the computation now with proper notation. I'll let you catch up here and think about what I would say next year. Okay, I mean, if these must be equal, can you think of an equation from that?
K must be equal to -2.
Yeah, but how do you get that?
Oh, we set it to.
Set these equal, right? Okay, this means, I'm okay with you writing your solution like this. This means 4 is 6 plus k, so -2 is k, a little bit off screen. I hope she's coming back. Any question here? That's the answer. Now, I do want to show a graph also, but let me put a, oh, wait, what happened? This easy? That's true. Okay. But it's going to be the same proof over and over. And yeah, that's not what Intro to Abstract is. Okay, so, and you're not disagreeing. It's just, yeah, it's a different course. Engineers don't usually do much proofwriting. They do sometimes derive formulas, like to come up with a new formula for a new situation, but they generally don't study abstract math deeply. We don't have as many engineers this semester, but a lot of you, even a lot of the math majors, are on the applied side. So the calculus sequence here at Ohio State, the lectures would usually show the proofs, but the students were not tested on the proofs. And they basically didn't learn the proofs, even though the lecturers would show them, because mathematically, it's the proper way to show it. I learned pretty early on here, even at Ohio State, that just calculus, given the audience, it doesn't really work well as a proof-based class, in my opinion. So, especially with engineers, it's just engineers are not trained to write proofs. Okay. I did want to show a graph. So like this graph, but now that piece will be down here. Okay, so if you plug in a -2, you get a 4 here. The graph, I'll bet I can draw it over here. Should I be worried that Aisha hasn't returned yet? Okay. We don't think she's in distress. It's probably distressing being away from mathematics. But really, wherever you go, there's mathematics there. So, okay. Oh, guess who almost got left in my refrigerator this morning?
Who?
Yeah. Yeah, my cat. Yeah, I was about to leave the apartment. I was thinking, usually my cat's at my feet when I'm leaving. And I have to remind him to stay in the apartment. I was thinking, my cat isn't here. Where is he? Looked around a bit, you can see him. And then I was thinking, I wonder if he's in the refrigerator. And he was. So,
So why is the cat refrigerator?
well, he was at my feet when I opened the refrigerator to grab my lunch for the day. And I guess I wasn't paying attention. Oh. Let me see.
What's your cat's name?
Lopi. Yes. Did you know that? Okay. Lopy. It's short for L'Hopital, who's a mathematician. L'Hopital's rule. So I think I'm the only person with a cat with that name probably in the world. You know, the world's a big place. There might be another. All right. Do I have a picture of my cat? I have lots of pictures of my cat. Oh, that's a good picture. Can you see that up there?
Oh,
He's an awesome cat. He's a little overweight. And whose fault is that? Mine. Yeah. Okay. Wow. That really makes me happy. I wonder where that is. He's next to a keyboard. Okay, that is an adorable picture. Oh, you missed the picture of my cat. All right, that's my cat. Are you a cat person? Not really. It doesn't charm you at all. And my cat is named Lopi, which is short for L'Hopital, who's a mathematician. And I almost left him in the refrigerator this morning by accident. So, but luckily I retrieved him. So would a cat be able to open a refrigerator door from the inside? I'm thinking maybe not. Okay. Would he be, would it harm him to be in a refrigerator all day?
Yeah.
It would. Okay. Not the freezer, but cat in fridge all day, question mark. Maybe I don't want to look that up and it'd make me very sad. But anyway, I'm glad I checked and got him out of there. Okay, he was very quiet too. He didn't say anything. There's more I could say about my cat, but I'll probably say it later many, many times. Okay, my cat is pretty awesome, not to put all of you down, but okay. Let's see. What time is it here? Oh, class is about over. Why is my phone vibrating? Potential spam phone call. Should I answer it? Let's not. Let's end early. I've been crazy enough today. So, oh, and Aisha, Bailey thought I should apologize to you. Why was I apologizing? Oh, for this bad graph. So I apologize. We thought that I may have driven you out of the room with all the what I was inflicting upon you. So, okay, why is my phone still vibrating? Am I supposed to like missed call? Okay. Hey, howdy. Yes.
When was section 2.2?
I think yesterday. Let me check.
Did I do it early? I think.
When did you hand it in?
on
What day?
Monday.
That would be early.
Yeah.
It doesn't have an E on it. Did you get it back today or yesterday? Really?
And then this one's early too, but it doesn't, it's not 5.5.
Is there a check minus on there? I don't know.
This is my resubmission.
Yeah, it looks like I graded that wrong.
And this one is early.
Okay, let me check that. You didn't get it back yesterday, though?
Which one?
The one that you handed in Monday? You got it back today?
Yeah, I got it back. Like, I don't,
You're sure you
took
handed
it
it in Monday?
yeah, because I
Okay.
do it before my programming class.
Okay,
So yesterday I had work all day, so it wasn't yesterday. And then
okay. It might, I thought I graded everything from your class Monday, but it might have gotten mixed in with another folder, which I didn't grade till last night.
Okay.
So put a note on that one saying it was handed in Monday and resubmit it and I'll fix that. Does that
Okay,
make sense?
And then.
The one with,
it
yeah,
doesn't need, but
I think that was another error on my part. Okay, put a note on this saying early question mark. It's not a question, but that way I'll know to fix it. Does that make sense? Sorry about that.
Do you have the 2.4? Because I don't have that here now.
Oh, yeah, I'll get it to you. You can also always get them on Moodle. They're in a lecture handout folder.
Oh,
I should have one here. That's not it. You're Hunter, right?
yeah,
Were you here last time?
I wasn't here yesterday now.
Okay, here we go.
Thank you.
Yeah,
can I just hand them to you?
yeah. Hunter, I think there may be other people that needed that also. I didn't even think of that. I thank you for asking. I got that to you. And Gracia, thank you. Howdy, you have a question?
Yeah, I was wondering.
Which one? 2-5?
Just reply to this Friday.
Yeah, it'll be due Tuesday,
So when is it?
Wednesday.
The next-
Well, okay, if we finish 2-6 on Friday, then the quiz will be Monday and the test will be Wednesday.
Okay.
Unless I don't get the quizzes graded in time, then I would delay the test. Because you need the quizzes back to study them. Does that make sense?
So like, we give us 2 days on that.
But I have to stay.
Yeah, yeah. The test is 2 classes after the last quiz before it. Unless I don't get the quizzes back to you in time. I'll talk about this more. Maybe even Friday, certainly by Monday. I do allow people to schedule makeups ahead of time. So if you think an extra day studying would help you, I'll talk about that. So you'd have an option for that as long as it's scheduled ahead of time.
But more than likely, the quiz will be on Monday.
Yeah, more likely than not. It's possible to be Tuesday instead. Yeah, since we didn't get as far today, and that was my fault. You too. Thank you.